Um, Good morning, good afternoon, good evening from wherever you are joining today. Thank you so much for being part of this webinar. We have a good amount of people here, so perhaps we will get started. Just a little bit about myself. I am Shashank. I work as a machine learning engineer at Walmart. Prior to this role, I've led data science and machine learning capabilities at Randstad and Monster, where I was responsible for making the search and recommendation models relevant using machine learning algorithms. And that ties in very well with the topic of discussion for us today, which is what are some ethical challenges as we integrate a lot of use of AI into hiring and workforce automation. So, enough about my background. Let's jump right into it. Um, so I want to start with this promise and peril of AI in hiring, because it's one of the few industry where we have two sides of the coins. Where on one hand, as we look at the trend for the past 5 to 6 years, we have seen a tremendous amount of integration of AI in hiring practices. Some of the numbers suggests that 80% of employers today are using AI tools in some or all stages of the recruitment. There have also been a tremendous amount of surge in recruiters adopting about how they use AI in the hiring practices. And there's also a lot of time saving component associated with it. So there's certainly a good amount of promise as it pertains to the integration of AI in hiring practices. At the same time, we have also seen the other side where more than 50% of US adults are expressing some form of reluctance when it comes to the use of AI in hiring decisions. We have also seen a good amount of adults who believe that there is certainly a bias when it comes to using AI in hiring practices, and a similar sentiment has been shared from an industry recruiter's standpoint as well. So this makes this a really good challenge where there is a lot of potential and promise. At the same time, how can we make sure that we are doing this in a more responsible way and in a more inclusive manner? Um, so what we are going to cover for today is, again, we're going to kick things off with an introduction. We're going to look at how the bias in AI essentially comes into play when it comes to hiring. What does our regulatory landscape looks like on a global scale? We'll dive a little bit on a technical end as well as how we think about bias. What are the areas from a machine learning standpoint that you may want to take into account? We'll look at the case study as well. And then finally wrap it up with some action items, more or less a blueprint that you can perhaps use to start to think about how one can integrate ethical practices into their AI development. Now, before we get started, I want to run a quick poll just to understand the audience better today. You should probably see a poll that has come up. So if you are looking at that, if you can take a couple of seconds to fill that in, that would essentially help a lot. Awesome, great. I'll let the poll run for some time, but looking at some initial numbers, we have a really good mix of people from the HR professional. We also have ML engineers, academic researchers, product managers. So it's a really nice group of audience we have today, and I hope everyone will have some or the other thing to take out of this session. So let's jump into the AI hiring pipeline. Now, this is not so much AI as it's more about when we think about what are some primary components when it comes to the hiring pipeline, right? So it starts from sourcing the candidates. The goal here is to have a diverse pool of candidates for any requisition or job that a company or as a recruiter is hiring for. Then it moves on to the screening round. Typically, these are the resume review, phone screening, skill assessment rounds, where the first set of filtration comes into play after the resume has been picked up. Then we have a selection round or interviewing round where the candidates are going through the interviews. Eventually, they would have cleared that, so reference checks, the skills demonstrations. And then finally, the evaluation piece, which is from an entire cycle standpoint. Once you're hired, you're going through the performance reviews, promotion cycles, retention tracking. And then, so why this as a pipeline matters for the discussion today is that when we start to think about bias, it's not so much in any one of these components within the pipeline. Every single stage has a potential to introduce bias. And the reason for that is AI today is being applied at every single stage. So if you think about it from a sourcing standpoint, right at the results that the candidates are seeing when you're trying to apply for a job. So as a candidate, if you're going on a job board, you're searching for jobs, the way jobs are ranked has a potential of how biases are introduced. Simultaneously, there has been a heavy use of recommendations. So as a candidate, as the jobs are recommended to you, there is a potential of bias in those results as well. And as we look at the screening selection, as we use more and more data to drive some of the stages, and as with data, there is an inclusion of bias, and as we introduce more algorithms, comes the bias as well. So I would want everyone to think of bias as not so much as an isolated piece that can get introduced in one of these components. It's more or less a horizontal layer where it impacts every single stage of the hiring pipeline itself. Now, when we think about different categories of bias, how should we think about that? And I like to break it down into three main categories. I'm sure there are a lot more, but this kind of helps us to basically understand and bifurcate what are the areas we need to look at. So the very first thing it starts with any ML or AI is data. So we're using a lot of historical data to train the models, and with the historical data, you have the past biases that have been in the system essentially propagates throughout the training and the deployment phases as well. So the historical bias is the very first point of introduction of bias into your system. So what's happening today along the lines? Essentially, your AI is learning from your past hiring decisions, and that includes all the biases that have come with it. What sort of impact does it have? A very good case we'll cover more in depth during the work case study is Amazon had a few years back an AI system that they were using for hiring. And essentially, because of how the past data had those biases, it certainly was penalizing terms and references that were related to women. So it's certainly a sort of an area where you have a significant impact if the historical data itself is biased. And so when you think about it from a critical question standpoint, as you start to use the data, the very first thing you want to ask for is, does my historical data represents who you have hired versus who did you hire? Meaning, if I'm hiring for an XYZ role, is my hiring decision purely based off of who would be the right person for that role, or is it more or less dependent on some protected attributes? Now, the second component in this puzzle is the algorithmic design bias. And what I mean by that is sometimes even when you remove protected attributes like gender and race from your model training, there are certain features who would end up serving as a proxy characteristics. A really good example of that would be a location feature or a zip code feature, where there are good arguments being made with regards to using location data to make the recommendations more relevant. But at the same time, certain Zip codes can essentially end up becoming a proxy for a race or a language patterns, and that starts to introduce the bias in your results. And so the question you need to be asking when you're choosing the algorithms, when you're choosing the feature set to train machine learning models is, are my algorithm finding patterns based off of the success, how they correlates with it, or is it simply based off of the privilege or a certain proxies that can be extracted out of the features that you are using? And the final piece is around the labels and the measurement bias itself. So you could do everything you can from reducing the bias in the historical data. You would choose the right algorithm and ensure that the feature selection is something that doesn't necessarily introduce any bias in your results. But you could also have a certain measurement metrics that itself introduce bias. So how exactly are your success metrics essentially set up? Is it optimizing for a certain amount of engagement or clicks, or is it optimizing for the right match? And so choosing the right metrics and what you're optimizing for also has an influence on your final results. And a connected piece to that is when we are talking about machine learning algorithms, you are usually having to deal with labeled data as what you would call as to be your ground truths. And with the biased data comes in the biased ground truths, and it kind of runs into this whole cycle. So having the right labeling strategy for your data in terms of what you define to be the ground truths and choosing the right metrics to optimize for also has an influence in how the bias is essentially driven through your overall algorithm development. Now, when we think about the biases in itself, there are also three vortices, as I like to call them, which are bias conducive factors. So one of them is an institutional bias. And consciously and unconsciously, there are certain decisions, there are certain cultural practices that starts to induce bias in how you are essentially practicing hiring to begin with. The second comes in with as an individual preferences. Now, the individual preferences at the end of the day, a lot of these operations and decisions are individual based, and with an individual comes in the individual preferences that again consciously and unconsciously starts to introduce the bias. And the third piece, which I've mislabeled here, is more about how do you position and market. So these are technology blind spots where when we are delivering the jobs, think about a scenario where you are on a job board searching for something. And in today's age, your results are oftentimes a mix of sponsored content versus organic content. And how you're delivering the sponsored content also have a play in how the results are skewed. Think about it from the NLP models that are being used to understand your resume, compare them with the job descriptions, and how that matching happens. So there are a lot of technological blind spots, and as we start to introduce more and more technology, and in this scenario AI, you have those blind spots that starts to conduce the bias. So I would think about this tree as interconnected pieces of factors that you want to take into account. And oftentimes, it's not that you have to solve the entire puzzle of it. And to be honest, it's an ongoing journey for every company. But even starting to address one or two factors that you find are something that within the institute or within the function that you operate can help mitigate that. It helps pushes the boundary to make the process more fair and transparent. So with that, I'm also going to publish another poll here just to understand if your organization today or the team or the function that you're part of measures any fairness metrics, and if so, how do you consider them to be? So just we'll take a couple of seconds to run that through. Great. I think we have some good responses coming in. And it's very natural and in line with how we are seeing it in an industry as well, where there are very handful of companies who would claim to have a very comprehensive set of fairness metrics in place today. And to be very fair, it's uh, an ongoing area where there are new metrics or new measures of fairnesses are being introduced. And so it's very hard to claim to have a comprehensive fairness metrics. But more or less, companies have started to adopt the diversity statistics and or at least having a lot of plans to have them implemented. Now, why having this today is important is because when we start to look at the global regulatory landscape, some of these things are not so much as nice to have, but are in some cases mandatory for you to have. Especially when we look at the European Union, there are certain laws today that have been put in place. They have had GDPR for some time now, which protects the sensitive data for the consumers. They also have non-discriminatory laws that prohibits direct or indirect discrimination. And more recently, they have come up with an EU AI Act, which again puts the use of AI in hiring practices as a very high risk classification. Similarly, when we look at North America and US in particular, we have a certain amount of rules. We have in California certain automated decision-making disclosures that needs to be in place. We also have Illinois AI Video Interview Act, which requires an explicit consent. There's a law in New York City as well. So there certainly are many statewide laws today in place we have in US, and there certainly are more in the pipeline. And when we look at globally, Canada has it, UK has it, Australia has it. Again, these are laws, they are maturing as we speak, but there certainly have been things in place today which makes what we are going to discuss today, if not all components of it, to be mandatory for you to have in place. And it's a rapidly shifting landscape that we would want to keep an eye out on quite actively. So let's try to get a bit technical here and talk about the fairness measures. Now, what I like to do is I like to break it down into different categories, and not all fairness measures are kind of in the same bucket. And so the categories that I have today is you have an outcome fairness metrics or the outcome fairness measures. And so the idea here is your focus on the metrics is to ensure that the algorithmic decisions have equal outcomes across different groups that you are measuring or running these decisions off of. And so think about, in terms of example metrics, you have a disparate impact, which is again the ratio of selection rates across different groups. Then you're talking about the true positive rate difference, which is the equality of opportunity for all qualified candidates. And then you have demographic disparity, which is difference in acceptance rates across different groups. Then we have a category of impact fairness measures, which is what are some downstream impacts or effects on candidates' life. Think about salary difference as one thing. The gender wage gap is another thing that comes to mind in this context. The third category is a lot more about representation. So you have a representational fairness measures here where your focus is to ensure that your algorithms are not stereotyping or is not catching up on language nuances here. So a gender bias score would be a really good one to think about when you think about it from a representational standpoint. Now, when we think about gender bias score here is not so much about genders. It's more about the language which influences whether the language is written keeping male in mind or female in mind, or is it a gender neutral statement. And then the last but not the least is a process fairness measures. And this is a lot more about how the information is flowing throughout the decision making process. And so you have a sensitive AUC as well as the mutual information as the metrics that you can think about. Now, from a compliance standpoint, typically you would find the disparate impact of 80% rule to be popular when it comes to the legal relevance. But no single metric is going to give you a complete picture of fairness when it comes to your algorithms that are in place today. And again, these are handful of it that you can start to think about, but it's certainly a suite of metrics that you would want to have in place for you to be able to get a complete picture on how fair and transparent your systems are. Now, given these metrics are also different stages of where and how you want to take this bias alleviation measures into practice. And so with that, you want to think about it as a three-stage process. It starts with, you probably would have heard often garbage in, garbage out. So similarly, bias in, bias out. So it starts with the pre-processing. So fixing the data that you're using to train your model is the very first basic step you want to take into account. And there are certain kind of approaches that you have that you can essentially leverage here. So start with reviewing and balance sampling, a very basic thing for you to have in place, because when we are looking at a lot of historical data, you would find that certain groups have a higher representation as compared to other groups. And so balancing underrepresented groups is a very basic thing you can start with. The second thing is you want to have a rule-based scraping. So try to identify which are gender identifier or proxies from your textual information, and reduce that or mask them before you use that data for training the model. And as you are in this day and age using a lot of NLP approaches, which converts your textual information into vectors, try to ensure that there are no directional embeddings that relates to a certain protected attributes. For example, if you have a vector representation for male versus female, there should not be a directional differences in the vector space as it pertains to those two words. So the subspace projection on how the information is projected on a vector space, you want to make sure that that's neutral as well. Now, once you fix the data, it's a good start, but it's also half the puzzle. The second thing you want to take into account is in-processing, which is fix the algorithm that you are using to train the models on in itself. So one of the things you can start to look at is an adversarial inference or decorrelation across the features that you have. How sensitive are your results based on certain attributes that you're using to train your model on? If you're dealing with a lot of textual information, which in this day and age, along the information we have, we often end up using it. Instead of using a conventional TF-IDF, which gives a certain amount of relevance to certain terms, try to use fair TF-IDF, which essentially reduces the weight of terms that are very group specific. So instead of just looking at the data and based on the term frequency in your data, you can compute what the weightage needs to be. Try to introduce an additional parameter where it further reduces the weight that are group specific in your data. And then last but not the least, try to add fairness constraints in your optimization algorithm in itself. So oftentimes our optimization functions are, we want to optimize on a click-through rate or an apply-through rate, but try to add in the fairness requirements in those optimization functions as well. And then we have the post-processing. So you have the right algorithm, you use the right data, but when the results are being shared, the ranking plays a very critical, important role in how the results are being presented. So think about it as a candidate, you are only applying to the jobs that are being shown to you. And if those jobs in the way how they are ranked itself are biased, you would essentially introduce that in your entire flow. So fixing the output or post processing the results that are coming out helps mitigate that as well. So your fairness measures are not so much as just handling the data or just handling the algorithm or just fixing the ranking. It starts from your pre-processing to in-processing to post-processing. And oftentimes in practice, what we have seen is fixing the pre-processing and in-processing has a significantly larger impact in building a more transparent system than just trying to tackle it at the post-processing level. The second thing that you want to take into account is also your model selections, right? So oftentimes we are dealt with this paradox of fairness versus performance. And as you start to think about the machine learning algorithms, it starts with as basic as a decision tree or a logistic regression based approach to as complex as in today's age using transformers and LLMs. And so the decision to use which of these algorithms for what you're trying to do, it has to take into account two aspects of it. One is the performance, which oftentimes as a data scientist, machine learning engineers, we are trying to optimize for. But then also the interpretability of the models and in which context we are trying to use this. Is it something of a high risk situation and it's under a highly regulated scenario? Then oftentimes we may want to pick or lean towards an algorithm like a logistic regression or a decision tree, which thus compromises on performance, however, ranks very high on the interpretability and for being able to audit the results and the chain of results that are coming through it. And for less risky scenarios or where the regulation is not so strong, you can use the de-biased versions of transformers where you may lose the interpretability, but if your data is de-biased, you can certainly use that in those contexts and scenario as well. So think about right model or right algorithm isn't always about just interpretability or just performance. It's a combination of how you are finding that balance. And within that balance, how do you get to the best results? We have about 2 minutes. So I'm going to jump to this ethical AI framework because at the very least, I would want the group to take out of it. So when we think about ethical AI as a framework within an organization, it's again not one unit or one team's responsibility. It kind of has different layers to it, and it starts from the data stewardship. This is where you want to ensure the ethical collection of data, processing of data, and you're preserving the privacy of the data. The second layer, as we start to use this data to train the model, comes in the modeling and the training layer, which is how you're choosing the algorithms and using the data to train the model. On top of that comes in the evaluation and validation. So are you quantitatively verifying that the data and the models are adhering to the privacy, fairness, and explainability standards? And at the very least, compliant to the regulatory framework in the market that you're operating under. The third aspect of it, or rather the fourth aspect of it, is around the deployment and operation. So you want to emphasize that these metrics that you have that measures the fairness, that measures the transparency, aren't necessarily ad hoc, but more so at scale that you can measure on an ongoing basis. And finally, last but not the least, you have a governance compliance oversight. So as you build the systems out, you want to ensure that there is a strong alignment with the global regulations and the ethical principles while you enable the continuous amount of auditing in the practice of the system that you are essentially building. And so with that, I think we are at the time. So I know I've kind of rushed through a couple of last slides, but please feel free to reach out to me if this is something you found interesting. And if you have more questions, that I'm happy to more than engage with you offline on them and deep dive into any of the aspects we covered today. You can find me on LinkedIn, shoot me an email if you can. And with that, thank you so much for being here. Hope everyone had some or the other thing to take out of this session.